Lesson 4.2 Rational Exponent. So, before we are getting into this topic, I want to ask you one question. If we have x squared equal to 4, how to find the x value from this equation? So we are taking square root and become plus and minus, so become x equal to plus and minus 2. That's how we solved it, right? Okay. So then we want to focus on what this means then here. Somehow we put it into x squared into the square root box, then it came out x here. Then can we think about this expression using the rational exponent? So let me give you one hint. So we're gonna make x squared to the something here, and it's going to be x. You may reference this property a to the m and n equal to a to the m times n. So we just want to make this single power here. Okay. So then we can make this. So x to the 2 times, I don't know what this is, must be equal to x to the 1 power here. So we take out only this exponent because base are already the same. Then 2, this unknown value must be equal to 1. Then you divide by 2. So this unknown value become 1 over 2. So let's double check whether this is correct. So x squared to the 1 over 2 power, which means x to the 2 times 1 over 2 equal to x to the 1 power. Make sense? Okay. Then this one must be same as this expression, because after we taking square root to x squared, it came out x. And now we also found out x squared to the 1 over 2 power also equal to x. So based on this fact, what can we generate? Square root a means a to the 1 over 2 power. That's how we can generate. That's the key point here. Now, then what about this case then? You may have heard cubic root a. So in this case, cubic root a cube must be equal to single a here, which means based on this concept, we can make property cubic root a means a to the 1/3 power. Similarly, if we do n root a means a to the 1 over n power. Okay? Then let's cover one more concept about the radical expression. Square root 3, square root 0, square root negative 3. Which one makes sense and which one doesn't make sense to you? So as you know, D is a fine, but not this one. However, what about this case then? Cubic root 3, cubic root 0, cubic root negative 3. They're all fine because all the power case, negative time, negative become still negative. So based on this, we can generate one concept. Square root n root a if n is even, then a must be positive or equal to 0. However, if n is odd, then a can be any value. Okay?